Good morning, everyone, and welcome back to Day 2 of Spark Summit Europe 2015. Today, we're going to be hosting our data science track the majority of the day in this room. And I'm really excited to start off with this first talk, as I think it's going to really kick it off well. She's a data scientist at Bitly and is going to really be talking about how do you do data science at scale. Please welcome Sarah.
Hello. My name is Sarah Guido, and I'm going to be talking about how I've been using Spark for data science at Bitly. So, overview for this talk, I'm going to talk a little bit about who I am, what I do, who Bitly is, and what we do at Bitly, if you haven't heard of us. Brief overview about why we decided to go the Spark route, where it fits into our architecture. Talk a little bit about a few different things I've worked on using Spark, and then I want to finish with a few issues that I've had using Spark, which, when it works, it's great. When it works. So about me, I'm a data scientist at Bitly. I've been working there for over 8 months now. I joined them back in February. Before that, I was at a very small startup in New York. I'm from New York. It's great. So Bitly, if you don't know what we do at Bitly, we shorten links, but that's not all that we do. So if you've ever, you've been browsing around the internet and you see those links that are like bit.ly, that's us, Bitly. We also have an enterprise platform for marketers where they can go in and look at, my links have received this number of clicks over this period of time. You can break your audience down by segment, like browser type, device type, geolocation, and so on. Right now, all very sort of surface-level descriptive stuff. So I'm also one of the organizers for the NYC Python meetup, which is one of I think it's the largest Python meetup group in the world, with, I think, around 7,500 members. And I'm also one of the organizers for PyGotham, which is a really awesome regional Python conference that happens in New York every August. So, as you can probably tell, my language of choice is Python. And I'll get more into that in a little bit. I am co-authoring a book on scikit-learn for O'Reilly Media. And finally, I'm on Twitter a lot, and actually that's probably the best way to chat with me about things. So I'm at Sarah_Guido. So about this talk, this is mostly a description of my workflow, how I use Spark, what I use Spark for, a little bit of an exploration of the different tools I've used within Spark. This is not an in-depth exploration of particular algorithms. So, for example, I go into LDA at one point, and I'm going to briefly describe what LDA is, but I'm not going to really break it down for you. This is not about building new tools on top of Spark, which would be really cool, but we are just not at that point yet. And this is also not any sort of ground truth for how you should be using Spark. This is just sort of, since Spark is relatively new and has only relatively recently gained traction, it's a little bit like the Wild West. Everyone's kind of using it a little bit differently. So take my workflow with a grain of salt. So why would I want to use Spark? So when I first got to Bitly, we didn't have very many tools in place for working with the large amounts of data that we had. So when I arrived, we were running MapReduce on our Hadoop servers, which is great. But trying to use MapReduce for exploratory data analysis is really kind of a pain. It takes, 10 minutes to figure out how to write the MapReduce job to, say, count how many clicks the New York Times received on its content in the month of February. I don't want to spend 10 minutes trying to figure out how to write the MapReduce job. I want to actually just, maybe write a nice little query. Select star from your click data where URL is like New York Times. I want to iterate, prototype quickly. I don't want to waste a bunch of time figuring out how to do it. I just want to be able to do it. Because our overall goal at Bitly is to understand how people not only use the product that we've created, but how people access content throughout the internet. Because so many people use our links, we have so many links everywhere, so we get this nice, interesting snapshot into what the internet is doing. So Bitly data. Sometimes people say big data and they don't really mean big data. So we legitimately have big data. Maybe not big data on the scale of Microsoft producing 10 terabytes of data a day, not quite that big, but still big enough that definitely cannot run it in memory on my laptop. So 1 hour of our decodes data, and when I say decodes, that's what we call our click data. So if you click on a bit.ly link, that's called a decode event. 1 hour of our decodes data is approximately 10 gigs, meaning that within a month we produce around 7 terabytes of data. So we were really looking for a solution to work with data at the scale, to work with data at the scale relatively quickly. So why Spark? So before I got to bit.ly, we had a hack week, Q4 of last year, where a group of the engineers actually started messing around with it, and they were like, oh, this is pretty cool. So when I joined, and I ran into all these problems trying to work with just pure MapReduce and Hadoop, and we didn't really have anything else in place. I was like, okay, so we've already started working with this tool before, maybe let's give it another try. So then we had another hack week, end of Q1, and got a nice little team together, and we just sort of played around with it all week. And that's when I realized it's fast. It's really fast. When you can get it to work, it's like really fast. It's great. Particularly of interest to me are the distributed scientific tools. You know, we want to do, I mentioned before that we have very surface level analytics in our enterprise product, but we really want to be more intelligent with the insights that we're delivering. So it would be useful to have some sort of distributed data science tools to actually deliver those insights. So Spark is very appealing. Also, I'm a Python programmer primarily, although now I'm probably going to go to the Scala route, which I'll get into a little bit later, but I love Python. I love writing Python. There's a Python API. Okay, check, cross that off my list. Cutting edge technology, literally cutting edge, with a new release every 3 months. It's very exciting, a little bit frustrating sometimes, but very exciting to be on the edge of a product that every time there's a new release, there's some new awesome update to it. And finally, the way that I'm using Spark is I'm running it on EMR clusters on AWS, which is great because we have all of our data stored in S3. When I first started working with Spark, I mentioned we have all of our data stored on our servers, so I was trying to work with Spark on our Hadoop servers, which was kind of a pain. But then I realized that we have all of our data duplicated in S3, so I could just run Spark on S3, or Spark on EMR, which was way easier. So lots of good reasons to use Spark. This is kind of the journey I've had over the past 6 months or so. So when I started playing around with it on our Hadoop servers, we could only run 1.2 on our servers because we were using CDH to manage it, and at that time, CDH only came with 1.2. Then made the switch to EMR, was writing Python. 1.4 came out, and I think a little bit after 1.4 came out is when Amazon officially started supporting Spark on EMR. So I started working more with Scala. And then now we're on 1.5, which is great. And now I'm primarily using Scala. Okay, so I mentioned before, one of our goals is to understand user behavior, how people interact with content on the internet, and so on. So how do I, go through a typical data science workflow, whatever that may mean, using Spark? So just for context, this is what a piece of our data looks like. Every time you click on a bit.ly link, it generates a line of JSON. So, and this contains information like the browser user agent, the country, time zone. We give it a global hash and a user hash, username if the person is logged into bit.ly, the long URL. So it's from the New York Times. Okay. There we go. So as any data science project starts, I want to actually retrieve some data. So the problem that I had was I wanted to retrieve only New York Times data. Because we have so much data, I figured I would start with a small chunk of data to analyze. So I want to retrieve only New York Times click data. So there's a couple solutions for this, and at the time I was using Spark 1.3. So this is how I was retrieving data using MapReduce. We don't really need to go over what this is. Just know that it's a lot of code. It's a lot of code for a very simple task. Blah, 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 MapReduce stuff. So this is 1.3 Spark syntax. So for Spark, it's way shorter. I read in the file, I run my nice little Spark SQL query, and there we have it. There we have data. It's so easy, it's so great, and I don't have to think about, oh, how does this reduce to this, blah, blah, blah. So I was playing around with Spark SQL and also implementation in pure Spark. And Spark SQL, to extract New York Times data from an entire day of decode data, which is around 240 gigabytes, took about 8 minutes. In pure Spark, it took 4 minutes, which is really super exciting. With this code right here, using a simple lambda to extract, it was just like, it was so ridiculously fast. And this was like the moment where I was like, okay, let's consider Spark seriously as a tool for data science here. So that's very exciting. Okay, so another problem we still kind of have, is that we have lots of links, New York Times links, BuzzFeed links, sports links, business links, so on and so forth, but we currently don't have a way to classify them as particular kinds of content. We can't say, this is a sports link, this is whatever, business link, this is a technology link. So I was looking into several solutions for this, one of them being LDA, latent dirichlet allocation. I also looked into some third-party stuff, and we've actually decided to go the third-party route, so spoilers. But this is a very interesting problem to approach using Spark. And at the time I was doing this, Spark 1.4 had come out, and I was using 1.4. I was also using Scala because 1.4 only had LDA in Scala. I think 1.5 has it in Python now, which is pretty cool. Okay, so LDA in Spark, it's a generative model, which means that for each topic, gives the probability that a particular word will be generated by that particular topic. LDA in Spark has several different methods, and it takes a term frequency vector as input. LDA comes with a caveat that it's still an experimental feature under active development, which is another one of the reasons why we ended up going the third-party route. Okay, so if we have, briefly, I'll go over what a term frequency vector is. So we have a group of text. Let's say we have all this text here. We need to vectorize it. So this is essentially what a term frequency vector is. You take each document and you take each word in each document and you essentially count how many times that word appears in a particular document. So you can imagine this creates a very large, very sparse vector. But actually doing the topic modeling in Scala is really easy. The code is very simple. So, I have my Spark context, I read in my file. I can set how many iterations I want, set K, how many topics I want to create, and then I just run it over the documents. And this is actually very fast for being fairly complex. And this is just on a small subset of text. But you can see, like, so here we have 2 topics, and then for each word, you have the word count, and then you also have the probability that that particular word is generated by that particular topic. The bottleneck, I should also mention, the bottleneck for using LDA with our current infrastructure setup is not with Spark, but it's with our web crawler. So we're sort of rewriting that, but to actually scrape all the text would be very inefficient. So unfortunately, we were not able to go this route, but very interesting. Something we are doing right now, though, which I'm super excited about, is trend detection. So, if we have certain enterprise clients like the New York Times, and they want to know when a particular piece of content is trending. So what does this mean? So the New York Times has insight into the traffic that its own website receives, obviously. But they don't really necessarily have insight into what of their content that other people are sharing. So because they shorten all of their links using bit.ly, we can actually see this information. We can tell them, outside of your own content, users are organically sharing this particular link, and this is really popular. Maybe you should repost this or something. So very cool, very interesting problem to solve. So I'm starting to transition to Scala, only Scala, for reasons I will get into a little bit later, which has been a little bit of an uphill battle because my first language was Python. So as you can imagine, Scala and the JVM is a little bit different. with this project, I'm finally starting to get a really solid workflow in place where I'm not really having to worry so much about how to actually make it work. It's just sort of set up to like work now, which is really great. And finally, what I'm going to talk about here is something that's really exciting to me because I'm at the very beginning of this project, which is very exciting. So I'm running Spark on EMR, and Spark 1.5, which is great. I actually, a couple weeks ago, I was messing around locally, and I was like, oh, I wonder if I could get Jupyter Notebook set up and use Spark with it. So I don't know if you're familiar with Jupyter Notebook. You'll see what I mean in a second, but it used to be called IPython Notebook, where you can basically run bits of code interactively, and it's really great for presenting, and I'll show an example in the next slide. But it works with Python. It used to be called IPython Notebook. So I was like, I wonder if I could set it up so it'll take like a Scala kernel, and I can run Spark with it and do essentially the workflow that I would normally do in Python. I can do it in Scala. So we have a very magical ops guy at Bitly who actually set this up for me. So I am running Jupyter Notebook on our EMR clusters using Scala, which is really great and really has sped up my R&D process because now I don't have to wait for the thing to compile, and then if it fails, I have to figure out why it failed because, again, I'm not super great at Scala yet, as you can probably tell from my code here. But so basically what I'm doing here, I'm reading in a file. I've created some functions to format the file. The goal here is that I want to take each timestamp, and I want to extract the hour and the minute because for doing trend detection, I need to keep track of how many clicks are occurring on links at a particular time. So I'm going to extract the hour and minute and then bucket the links by minute. So that's what that format date function is doing. And then the format URL function is extracting just the host and the path because I don't need all the query parameters or anything like that. And then here, this is just, oh, it actually works. So, you know, I created a user-defined function. I ran it on the different columns. And here we have a nice little data frame by minute each URL. And I did this all in Jupyter Notebook, which is really cool. I'm very excited about that. Okay, so right now, we are not using Spark in production. Actually, how many people are using Spark in production? Can you raise your hand? I'm very curious. Okay. Another thing I'm curious about. How many people are using Python in Spark? How many people are using Scala in Spark? Okay, that's interesting. There's like equal numbers of people using Python and Scala. Okay, so I've decided to go the Scala route because, well, there are a number of reasons. First of all, I'm sure you've seen this little graph before. Scala in pure Spark, and especially with RDDs, is way faster than Python. I'm not necessarily going to be doing everything in data frames all the time, even though the data frame performance is comparable. And also, it seems like the development of the Scala API outpaces the Python API. So, for example, LDA was not in Python until the most recent Spark release. So I can't really necessarily wait around for the tools I need to catch up, nor do I really have the time to, you know, submit a pull request myself. So I've decided to go the Scala route, and I think a lot of people have also decided to go that route, although Python will always hold a very special place in my heart. Oh, and I should also mention, we not only for trend, so obviously trend detection, you know, we want to do this in real time, so this is a really great use case for Spark streaming when we get there. And I was actually really excited to hear that Spark 1.6, I think, is going to combine streaming and data frames. That's super exciting. But we've also been talking about replacing a couple other parts of our system with Spark streaming, which is very exciting. There's lots of buy-in across Bitly for actually using Spark and moving forward with it, which is really exciting. So I've had some issues getting it to work, and I really want to talk about these because I think a lot of the time we talk about, oh, Spark is so great, it's so fast, blah, 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 this is awesome. But actually, it's kind of a pain to get it to work sometimes. So when I first started working with it way back in, I don't know, March or April or something, I mentioned that I was trying to run it on our Hadoop servers using 1.2. Well, first of all, had to use 1.2 because that's the latest version that had come with CDH at the time. But 1.3 was out, and 1.3 was when data frames were released. So I couldn't use data frames. And also, we could only have it set up in standalone mode on the Hadoop servers. So there were a bunch of us trying to run jobs. And since standalone runs in a first in, first out method, it was just a huge bottleneck. We were like, okay, this is not a viable solution. After that, I had gone to PyCon actually and talked to people, and they were like, why would you ever run Spark like this? Run it on EMR. I was like, okay, great. So I went back and ran it on EMR. It was great. So the JVM, for someone completely unfamiliar with Java-based languages until a couple of months ago, the JVM is very frustrating to work with. Scala syntax is actually like not bad, pretty easy to read. Some of it's like kind of similar to Python a little bit. But the actual like JVM environment is really frustrating sometimes. You know, there's Java heap errors all over the place that, you know, when I first saw those, I was like, I don't know what these are. The other Python people on my team were like, I kind of remember this back from my undergrad days like 10 years ago. So it was a little frustrating. I think that'll get easier the more stable Spark becomes and the more familiar that we all become with the JVM and how to use Spark in that context. So another huge problem we ran into, so we have all of this data and it's all stored in gzipped files. So when I was first trying to run my New York Times extraction code on these files, it would take about 30 to 40 minutes to process 1 hour's worth of data. And I was like, this cannot be right because this is so slow, this is not scalable or sustainable or anything. Then after Googling around a bunch, come to realize that Spark doesn't actually automatically partition gzipped files. It takes it in as one whole partition, which is why it was taking 30 to 40 minutes to process one file, which was like not super apparent at first. And I think this was before the Spark data sources thing was even a thing. This is many months ago, but it's very difficult. But you know, we figured it out, and then once we started unzipping the files and or repartitioning them, it's like, oh, I can extract from 240 gigs worth of data in 4 minutes, which is pretty good. Another thing that was kind of interesting was dealing with resource allocation on EMR. So for a while, trying to get the most, I guess, efficiency from our EMR clusters was really kind of a struggle. At this point, was when I was like, hey, ops guy, can you help me figure this out? There's like not a lot of really great documentation. I mean, there's a couple like Cloudera blog posts and whatnot on how to like really effectively optimize your EMR clusters for Spark. I think that's because obviously like Amazon only very recently started supporting Spark on EMR. So that's kind of the missing link, I think, for some things. Finally, like the Spark documentation is great, but there's still a lot of holes in it. You know, it's really only recently gained traction, so I think obviously the more that time goes by, the more Stack Overflow questions that will get answered. But there's occasionally some stuff that's just like, oh, no idea how to do this. All right, let's just try and figure it out. So where to go next? Spark in production. I would love for us to be able to say that we are running Spark in production. And my goal is that with this trend detection project, which hopefully will ship Q1 of next year, we will actually be using Spark streaming for that. That's sort of a larger question with the rest of engineering, but I'm really hoping that we can effectively use Spark in production. And then we can tell everyone about it. You know, say, this is how we're using Spark in production, because that's a little bit more interesting than just saying, this is how I'm using Spark for everything except production. Really want to use it for various parts of our app, not just the data science end of it, but like I said before, we have certain systems that we want to replace, possibly with Spark streaming. Yes, and use it for R&D, prototyping purposes. The more interesting features we can build, the better our product will be. One of the other reasons that we're going the Scholar route, which I didn't mention before, is GraphX. GraphX is really interesting, and there's a lot of really interesting problems out there that are graph theory problems. So it would be really interesting to incorporate that into some intelligent part of our app. So all of the material that I've come up with today is from these sources. So obviously the Spark documentation, the Databricks blog. The Databricks blog is great. I don't know if you're reading it, but you should be. Everything they post tutorials, they post this is what's new in version 1.n of Spark is really helpful and really awesome. So thank you, Databricks. The Cloudera blog is also really great. I don't know if you're reading that, but they have some really interesting stuff sometimes. And finally, one of the most useful resources to me so far has been other Spark users, just chatting with people about the problems they've had, how they've solved particular issues, how they're actually using Spark in the real world. It's great, so that's very helpful. So that's all that I have. That's my Twitter handle. Yeah, thank you for attending my talk, and yeah, we have some time for questions.
We have some time for questions. All right.
All right.
Thank you, Sarah.
Yeah, thank you.